we are going to do a presentation on periodic stationary process. I'm going to introduction part and in time series analysis, stationary is the important concept. A stationary time series in the one whose stationary properties such as mean variance and autocovariance remain constant over time. The autocorrelation function measures the correlation between a time series and its logged values. The autocorrelation function is important to diagnose the stationary of a time series. In stationary time series, the autocorrelation function will rapidly decay to zero as lag increases. The ACF does not decay rapidly. It suggests that the time series may not be stationary. The first point. The stationary process is one where the mean and coefficient does not change over time. It's technically second order stationary or weak stationary. A weak stationary, a stationary process also weak stationary process or second order stationary process. It is a circuitous process whose statistical properties such as mean and variation does not change over time. And then second point, in first order stationary, the distribution of a xt plus x1 comma and then up to kt plus k is the same as x1 to xt xk for all value of t and k. First order times is also weak represents are covariance status stationary. It's a weak form of stationary and second order stationary. Okay, and then the series is stationary through its autocorrelation function, like rho k equal to correlation between xt comma xt minus k. And the third point is the final point. When the ACF of the time series is slowly decreased, this is an indication that the mean is not stationary. Conventionally, a stationary series should convey on zero quickly. And that's all my point. And now over to
We are going to see the topic stationary of white noise. Stationary of white noise is a time series which is observation is the random and independent realizations of normal distribution. It always with the constant mean and variance. The constant variance and mean of the white noise do not change the time and the function is always zero. The autocovariance function of the white noise is also zero for all the lag expect for zero. Therefore, white noise satisfies the conditions of the stationary process and serves as a useful benchmark for testing the stationary of more complex time series model. We are going to see the functions of mean and autocovariance formula is given below. This is the autocovariance and mean functions of white noise. Next we are going to see the stationary of moving average, and moving average is a type of stationary time series where each observation is a linear combination of current and past error terms. Note that linear combinations of current and past error terms assumed to be IID with zero mean and a constant variance. Next, the 3 points moving average process of is stationary because the mean and autocovariant function this is the form of 3-point moving average process is independence of time t satisfying the conditions of stationarity. The autocovariant function is given by this part. It is a symmetric about log 0. Next, stationary of random walk. A random walk is a non-stationary time series which each observation is a sum of previous observation and random stock or innovation term. What that? The sum of previous observation and random stack of innovation term. Specifically, the model for the random walk can be written as st equal to st minus 1 plus sum of t. The sum of t is the random stock at a time t, and xt minus 1 is the previous observation. Because the stationary as a remove the trends and make the mean and variance constant over the time. In other words, the first difference of the random walk is stationary process known as random walk with drift. Also, the random walk with drift violate both conditions of stationary because the mean function this is also functions of t. That's all.
Next, we are going to discuss about the topic properties of stationarity. Slide change. First, in properties of stationarity, we have 5 categories: strict stationarity, weak stationarity, time invariance, and randomness, mean reverting behavior. Strictly stationarity means in this assumption it is too strong and difficult to test for using a single data set. Weak stationarity or second order stationarity. A time series is weakly stationarity if its means variance or autocovariance do not change over time. Time invariance, statistical properties of a stationary time series remain constant over time and are not affected by the specific time period when data was collected. Randomness, the absence of a trend or pattern allows the statistical properties to remain constant over time. Mean reverting behavior, this is often observed in financial time series like stock prices, which tend to fluctuate around a long-term average value. Next, there are 3 types of stationarity: weak stationarity, trend stationarity, and joint stationarity. Now we are going to discuss about the weak stationarity. Weak stationarity is also known as the second order stationarity. It is weaker form of stationarity commonly used in practice. Specifically, a weakly stationary time series has a constant mean and constant variance and an autocovariance function that only depends on a time lag between the observations. Next slide. The mean function of weak stationarity is E of xc is equal to mu t. It is independent of the time t. So then mu t is equal to mu. The autocovariance function of weak stationarity is t of x plus t of h, t plus h comma t is equal to covariance of xc plus h comma xc is equal to covariance of xt xh comma x0 is equal to gamma of h comma 0. That's all my topic.
Trend stationarity. A time series process is trend stationarity if its mean and variance are constant over time, but the autocovariance function depends on the time lag. This means that statistical properties of the process are time invariant, but the mean and variance may be affected by the deterministic trend. Thus, the model may be considered as having stationarity behavior around the linear trend. This behavior is sometimes called the trend stationarity. Example, the price of chicken series. Joint stationarity. It refers to the properties of multivariance time series where all the individual time series are stationary and their cross covariance function only depends on the time lag between observations. In other words, the statistical properties of the joint distribution of all variants in the time series remain constant over time. This property is important in many applications such as econometrics, finance, and signal processing.
This part is conclusion. Time series analysis is a powerful tool for understanding and forecasting pattern in data that vary over the time. By analyzing the statistical properties of the time series, we can identify trends, seasonal patterns, and other features that can be used to make a prediction about the future value. To conduct time series analysis, it is very important to ensure that the data is stationary or that it can be transformed to achieve stationarity in order to apply appropriate model and methods. Thank you.